Okay, welcome back to math class. Today we're looking at section 8-10. Hopefully you remember last week doing slope and graphing lines. Today we're doing systems of equations, and a system of equations is when we have two or more equations with the same variable. Now what this means is, if I was to graph these two equations, then I would have two lines on my graph. The one important thing to note about systems of equations is the solution to a system of equations is an ordered pair. Hopefully, at this point, you're familiar with what an ordered pair is. Just in case you forgot, it's our x and our y coordinate, like this. So essentially in this lesson, you're going to be given two separate equations, and you're going to have to figure out what point is true on both lines. There's two ways that we can do this. We're going to look at one way today and one way tomorrow. But today we're going to do it just by graphing the two lines and figuring out where the two lines intersect, because that's going to be the point that's true of both lines. Right, so let's practice. If I gave you the equations y equals x plus 2 and y equals negative 2x minus 4. We're going to use our graphing skills just like we have earlier in the chapter, everything we've learned about slope and slope-intercept form. And we're going to graph these two lines. So first things first, let's make our graph. Okay, now when we let's look at this first equation and figure out how to graph it. The first thing we need to do when we look at this equation is look for the y-intercept. Now the y-intercept in this equation is 2. So I'm going to come over here to my graph. Remember, we have our y-axis is the one that goes up and down, and our x-axis is the one that goes side to side. Now I'm going to take my y-intercept. My y-intercept, you should know, is where x equals 0. So we're not going to go out any because x is 0. I'm just going to count up 2 spaces. So that's my y-intercept. Now my slope here, it just says x. It doesn't say x times anything. So what we know in our heads when we look at this is that this is like saying x times 1. So our slope in this equation is 1 over 1. So I'm just going to start at my y-intercept. I'm going to go up 1, over 1. Up 1, over 1. And then we'll connect these dots to make ourselves a line. Now I'm going to do the same thing with the second line. Now the second line says y equals negative 2x minus 4. So our y-intercept looking at this line is going to be minus 4. So I'm going to start at 0, right? Because our y-intercept means we don't go out in our x-axis. And I just go down 4 spaces. 1, 2, 3, 4. So there's our y-intercept to this other equation. What I'm going to do now is find my slope, which is negative 2 here, Now if I see that the slope is -2, what I should be thinking is it's -2 over 1. So I'm going to start here at this point and I'm going to go down 2 over 1. Now just to make, I'm going to go down 2 over 1. And then I'm going to connect my points just like I did before. Okay, so we've graphed our two lines just like we've been doing. We've been doing only one line up until this point, but now we've got both of these lines graphed, and the solution is the ordered pair where these two lines intersect. So if you can see where they cross, it's going to be right here. And that looks like it's at when x is -2 and y is 0. So my ordered pair is going to look like this, -2, comma, 0, because we always do x first and then y. Now that's the place where these two lines intersect, so that's the solution to our graph. That's all you need to do is graph them and find the place where they intersect, and you have your solution. There are two other things we need to go over really fast. Two, what I'm going to call special cases, because normally you'll just draw those two lines, wherever they intersect, that's your solution, that's the answer. But we have two special cases where where you don't have to do that much, where you don't have to do the same things. The first one is if our lines are parallel. Hopefully you guys remember what parallel means. Basically, parallel means we have two lines with the same slope, and our graph of those two lines, they're never going to touch, right? They're parallel, that means they have the same slope, that means they're going in the same direction, which means they're never going to cross, which means there's not an intersection point at all. So what you'll write is no solution, because there's no place where they intersect, so you can't find the solution. That's all you have to write is no solution. The second special case is if you start graphing it and both equations go to the same line. Both equations are for the same line. That means you're going to start to graph it, and I'm going to make my graph, and then I'm going to draw my line, and then I'm going to try to draw the second line, and I realize it's the exact same line. If that's the case, then all of the points on the line are a solution, right? And so we write infinite solution. Infinite solutions. So those are my two special cases. Normally, you'll just graph the two lines, and wherever they intersect, that's your solution. But sometimes they will never intersect, and there's no solution, or they'll be the same line, and it's infinite solutions.